Okay, so those are the features on which these two domains differ. Then there are three more on which they agree. So the textbook draws a distinction between episodic and sequential tasks. So an episodic task, every action of the agent is evaluated independently. So an example of an episodic task would be a medical diagnosis agent. So an agent is given a MRI scan of a patient, and it has to come back and tell you whether that patient has cancer or Alzheimer's or something like that. And each patient is independent. It evaluates one patient, gives an answer, and then evaluates another patient. That would be an episodic task. These games are sequential because the agent has to do a long series of actions and then just gets evaluated at the end of the game or at the end of a point. Known versus unknown. So this is about the rules of the game or the world model, right? So these games are both considered known because the agent knows the rules of the game. They know what's going to happen when a certain move is made. Now, if you want to know an example of an unknown environment, well, there are some situations where agents are trying to learn a game and actually don't know the rules of that game. You know, that makes it harder. Or if you look at something like Infinite Mario, the best players of Infinite Mario have been made by reverse engineering the physics. But that's actually, and the same thing with Pac-Man, but it's not easy to do that because the physics in Mario is not the same as the physics in the real world, right? If you fall down a pit, you can actually somehow jump back out of it or something, which you can't do in real life, by the way. But people who play too many video games. But so if you're learning Mario and you actually don't know the physics, then it becomes an unknown environment because you don't know the world model. So it's not just the game itself, it's a matter of what information is given to the agent. And the last one is single versus multi-agent. Okay, so both of these are multi-agent tasks. Now, if you want to ask what's an example of a single-agent task, well, solving there are games that you play on your own. There are card games, solitaire card games, or solving puzzles. Like Sudoku or Rubik's Cube. That would be a single-agent task. Okay. So, any questions about this? Yes.
For each league, is the hardware basically standard and assigned to both teams, and then they just write the software for it?
Good question. So the first video, the two-legged and the four-legged videos, yes, that is the case. It's sometimes called the Standard Platform League. The RoboCup SPL stands for Standard Platform League. So in that case, everyone has the same hardware, and you just have to, it's just purely about software. And there were some weird cases. I think this French team was actually, or this team from Osaka was double clocking the CPU of the robots and making them move faster and stuff. And there was a discussion whether that was legal. But the other league, the small size league, is different. You actually design and build your own robots. And the match that I showed you, the two teams happen to have a pretty similar design, but there's actually quite a bit of variety there. Yeah.
And is all the information there coming just from the cameras, or do they have other sensors as well?
These are very good questions. So they usually have bump sensors. Oh, the other sensors, right? Well, let me just. Since you asked, let me just go back to, I think I got, okay, so let me ask you what sensors, have a look at the picture of this robot here, and what sensors can you see on this robot, or what sensors do you think it has? Laser. Sorry?
Laser front or not? Like the
it does, yes. It's not a laser, but it's actually infrared distance detector, yeah.
Camera?
The camera, that's right, the camera's actually in the nose there. Camera's here. What else? That's right, it's got touch sensors in its feet, little pads there, and it can detect when they've been pressed. And then it's actually got ears. Yeah, it's got a microphone there. Yeah, so it can process some audio signals. The audio signal is pretty bad because it's kind of, there's all this noise from the motors and stuff, but it can respond to some commands. And what about actuators? What can it move? It can move its legs, yeah, so it's got these joints here, the shoulders and the knees. It can wag its tail, although that doesn't really serve any purpose. But it looks cute. It can open its mouth, and it can turn its head, that's right. And it's got a few LEDs here that it can light up as well. And actually, I'm not sure whether it was this model here or the one that I showed you in the video actually has a sensor to tell whether the mouth is open or not. And our team actually used that because what the robots would do is they'd get to the ball. So they had this thing where they'd go to the ball, where they'd put their arms out to collect the ball, and then they would stand up and then they would try to kick it. But sometimes the problem is if the ball is under your chin, because the camera is in the nose, if the ball's under the chin, you can't see it. So sometimes the ball would get knocked out of the way, and then the robot would still try to kick the ball that wasn't there. So these guys came up with a very ingenious way around this, that the robot opens its mouth, and then it moves its head down, and if the ball is there, the mouth will close, which it can detect. So it actually does use the mouth sensor. It actually did use the mouth sensor for a useful purpose, to test whether it still had the ball. Okay, and sorry, in the small size league, they usually have bump sensors as well, and some of the teams were really, actually, I mean, these videos are some years old, but the Koreans had pretty fast robots. And if you look at the videos, the modern day videos, like, you have to sort of put it in slow-mo to see what's actually going on. But so for the really fast-moving robots, the overhead camera doesn't give you the feedback fast enough, so they have to supplement it with onboard cameras. Yeah. Okay, so where are we? Yeah, so let's just go through a few other. Yeah, so just as RoboCup, you see a dramatic difference. So let's just go through a couple of other domains. So let's look at Wumpus World. So is it simulated? Yes. Is it static? Or yes? Is it discrete? Yes. Is it fully observable? No, we talked about that. Is it deterministic? Yes. Is it episodic?
Yes.
Sequential. Is it known? Yes. And is it single agent? Yes, it is single agent because we treat the Wumpus as a natural feature. You know, the Wumpus just sits there, and if you come near it, it eats you. If the Wumpus could actually move and make choices, then we would start to regard it as multi-agent. And yeah, the thing about deterministic, yeah, so there is some randomness in the environment, but the randomness is all at the beginning in the usual formulation. We assume that the environment has been generated before the game starts and doesn't change afterwards. So the environment is there, but there are things about it that we can't observe. And then as far as games go, so we talked about chess now. What happens if we look at dice games? So this is a game called backgammon that many of you may be familiar with. I did some work on this some years ago, but there's a family of games basically where you roll the dice and you move pieces around the board and you can decide which pieces to move and you can capture other pieces. So it's a combination of dice rolls and strategic choices. So given that, what would you say about this? It's simulated, yes. Static, yes. Discrete, yes. Fully observable, yes. Okay, well, let's just cut to the chase. So it shares with chess the fact that it's simulated, static, discrete, sequential, known, and multi-agent. So the real question is whether it's deterministic and whether it's fully observable. Now, normally we consider that it's fully observable and stochastic. So that means everyone can see all the information, and then when you roll the dice, it's really random which dice are going to come up, but as soon as they're rolled, everyone can see them, right? Now, this is a slightly, you might consider this a philosophical point, but I think it's interesting to sort of think about this. When we play it on a computer, sometimes the dice rolls are generated by a random number generator, and if you give that random number generator the same seed, it'll generate the same sequence of dice rolls. So if we think about it in that way, you could actually think that it's deterministic but partially observable. Because you could say, well, because the seed has been determined, the dice rolls are actually predetermined, but I don't yet know what they are, right? So you've got this funny sort of thing. You can see it in two different ways. You could either see it as fully observable and stochastic, or as deterministic and partially observable. And this is, this relates to philosophical debates. This view about it being deterministic but partially observable, that philosophical view is sometimes referred to as neo-Calvinism, because there are some people who believe that God that God knows everything that's going to happen in advance. It's all predetermined. It's just that we haven't observed it yet. And there are other people who don't believe that. So it's sort of it feeds into these philosophical debates. But we have the choice here, which one is which. And I bring this up because, many years ago I wrote an AI backgammon player and we put it up on the web so people could play with it over the internet. And this was in the early days, in the 90s, of people doing this. And we would get emails from people who were absolutely convinced that we were fiddling with the dice rolls and, and generating dice rolls deliberately that would be good for our player and bad for them. They were absolutely certain this was happening, but in fact it wasn't. We were just generating them randomly. And finally we get to card games. So again, different people among you would be familiar with different games, but you can think of, some of you may play Mahjong, poker, rummy. Mahjong is a card game too, really. You shuffle cards and you deal them out, and then you play the games. Now, okay, so you've got this, again, this issue of stochastic versus deterministic. If the cards are shuffled at the beginning of the game and then just dealt out, we could, if we want to, think of it as deterministic. If you reshuffle the cards in the middle of the game, then we have to think of it as stochastic, really. But the more interesting point is about fully versus partially observable. Card games we have to regard as being partially observable, and the reason is that there's some information which one player has and another one doesn't. So this guy can see what cards he has, but the opponent doesn't know. So that's why we have to see it as partially observable, because and this is what makes card games actually really hard, is that there's information that's available to one player and not another. But there's been various, so you have to use pretty sophisticated techniques for this, but there's actually been some interesting, very recent work about Texas Hold'em, poker, and so on. This issue of situated, okay, so all of these, you realize that all of these things we had like a binary decision. You know, it's either fully or partially observable, it's either episodic or sequential, it's either static or dynamic. Now what about simulated? What's the opposite of simulated? And there were lots of discussions about this, and most people I think have sort of accepted this view that was put forward by Rodney Brooks in 1991. So in a way there's kind of two opposites of simulated. One is situated and the other is embodied. And so situatedness, the robots are situated in the world. They don't deal with abstract descriptions but with the here and now of the environment, which directly influences the behavior of the system. Embodied, the robots have bodies and experience the world directly. Their actions are part of a dynamics of the world, and actions have immediate feedback on the robot's own sensations. Now, so how can we see the difference between this? Well, something that's situated by but not embodied would be, let's say, a high-frequency stock trading system. So it's a system that's buying and selling stocks, exchange-traded stocks electronically. It doesn't have a body. It usually just operates electronically, but it is situated in the sense that it's really trade. It's not playing with play money. It's really playing with real money, right? So that's the way it's actually having an effect in the world. And the same thing with an airline booking system. It's actually making real bookings for real planes, but it itself doesn't have a body. Actually, I heard something interesting last year about the history of this high-frequency trading. The first people who did it in the 80s, the first guy who was doing this in the 80s, there was some terminal, and normally a human would sit and type the orders in at the terminal. So this guy got rid of the human, and he just plugged the cable into a computer and got the computer to send the signals. But then the regulators from the exchange came and complained, and apparently there was a clause in the contract that said all trades had to be typed at the keyboard. So you know what this guy did? He built a robot that would type at the keyboard. It had one finger for each key, and it would actually type all the orders at the keyboard. But he said they had to put it in a separate room because it made a noise like a machine gun. So in that case, it would be embodied. Now, what about something that's embodied but not situated? Well, if you think about those old-fashioned industrial robots that weren't mobile, like you'd have a robot arm that would come and spray paint the chassis of a car. So like, the chassis comes along on a conveyor belt. The robotic arm sprays the paint in a predetermined sequence, and then the thing moves on. We usually regard that, it's embodied because it has a physical presence in the world and it's spraying paint, but we treat it as not situated because it doesn't have any sensors, and it always just sprays in the same pattern. So if the conveyor belt broke down and the chassis wasn't there, it would just like spray into the air, sort of thing. So this is this difference between situated and embodied. Okay, so that's the summary. The tasks and environments can be classified in these attributes, and the environment type strongly influences the agent design, which we'll talk about in the next section, but that'll actually be so next week we'll talk about the agents at the beginning of next week's lectures, and then we'll move on to search strategies.